All right, the last one that we did from our class today involved a double angle. Sine of 2x is equal to root 2 over 2. Sometimes when you see a double angle like that, sometimes that means you're gonna use one of these double angle identities to help you solve this. Now in this one, I'm probably not going to use the sine of 2 theta equals 2 sine theta cosine theta, because if I was to substitute that in right there, then I'm bringing both sine and cosine into my problem, which sometimes is a problem. It makes it a little bit more complicated. So what I'm going to do is kind of like on the previous video, I'm going to create a dummy variable here. And I'm just going to say a is equal to 2x. And I'm going to look at this problem as the sine of a is equal to root 2 over 2. That ratio should be a clue to you. Root 2 over 2, that comes from one of our special right triangles, the 45, 45, 90, or in this case, because I'm working in radians, the pi over 4, pi over 4, pi over 2 triangle. And so if I'm thinking about the unit circle, because that's all we do in this unit is we think about the unit circle, I could go ahead and draw this, and a pi over 4 or 45 degree angle right here, pi over 4, okay? The sine of that, okay, right here is the y value is root 2 over 2. So one of my answers for A is going to be pi over 4 radians, okay? But there's also, where else has the same y value? It's over here in the second quadrant. So I've also got this angle. Okay? That's okay, I just need to go over there. There's different ways you could figure that out. Like probably what I would do is do pi minus pi over 4, like a half rotation minus that angle right there. And that would give me 3 pi over 4. So 3 pi over 4, if I put that in there, is going to give me also a y value of root 2 over 2. Okay, so a is equal to pi over 4. A is equal to 3 pi over 4. But this problem's not asking a. Remember, I just created a myself to help make the solving a little bit easier. A is equal to 2x. So let's bring 2x back into the problem. So 2x is actually equal to pi over 4. And 2x is equal to 3 pi over 4. All right, so to solve for x, actually all you have to do is multiply both sides by a half. Cancels that, and you get x is equal to pi over 8. That's one of my solutions. And same thing over here, multiply by a half, and you get x is equal to 3 pi over 8. Cool, so there's 2 of my answers. But how many solutions is this going to have? You always have to go back to the domain. Both of those are between 0 and 2 pi, which is great. Now, this is where you got to think about like the graph of sine of 2x. Because what's the period of that, okay? Like if I just said what's the period of sine of x, the period is 360 degrees or 2 pi. But if I put a 2 in here, that's going to transform my graph, okay? And remember, this is like usually represent with the letter B, but the period is always equal to 300. Oh, let's not use 360 because this problem is being solved in radians. The period is equal to 2 pi divided by whatever that B value is. In this case, it is 2. And so 2 pi divided by 2 is pi. So if I was going to be graphing sine of 2x, it still has the same sine wave, but the period is actually pi. And so if I was going to graph all the way out to 2 pi, and I want to go out to 2 pi on this problem because the question's saying find all the answers between 0 and 2 pi, it's going to look something like this. Root 2 over 2 is going to be some decimal. You may know it, you may not. But that decimal is a positive number. And if I just drew a horizontal line right there, okay, you can see those two graphs intersect at 4 different places. Now, the first 2 intersection points, we've actually figured out. The first one happens at pi over 8. The second one happens at 3 pi over 8. We did that over there with our algebraically. Well, how are we going to get these other 2 solutions? Well, instead of adding 2 pi, okay? Because that would be if the period was 2 pi. To get from, for example, pi over 8, to get to that next solution, the graph repeats itself every pi places. So then I would need to take pi over 8 and add pi to that, or pi over 8 plus 8 pi over 8, because I need a common denominator, and I'm going to get 9 pi over 8. That is going to be this solution right here, 9 pi over 8. And what about the last one? Well, I need to add 3 pi over 8, and I would need to add a pi to that. So 3 pi over 8 plus 8 pi over 8, and that's going to give me 11 pi. That's a bad pi. 11 pi over 8. And that would be this last solution right here. So this problem has 4 different solutions. X equals pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8.